Dear friends, in this video lecture we are going to explain one more important phenomenon of liquid which depends on the surface tension of liquid, and this phenomenon is capillarity or capillary action. For that, let us consider we got a liquid, here as an example water, and a tube with very small bore which is uniform throughout its length is called as capillary tube. Let this tube of very small bore which is uniform throughout its length is dipped in water, then water rises inside this tube above the water in the glass. Instead of that, if the same tube which is called as capillary tube is dipped in a mercury, then mercury depresses inside the capillary tube as compared to liquid outside the capillary tube. This rise or fall of liquid level inside the capillary tube as compared to liquid outside the capillary tube is called as capillarity or capillary action. Why it happens so? For the liquids which partially weights the solid or which totally weights the solid, the angle of contact theta is less than 90. The adhesive force is greater than that of the cohesive force. Adhesive force between the liquid molecules and the solid molecule is more than the cohesive force between the liquid molecules. Therefore, the molecules of a liquid which are in contact with solid has a greater adhesive force, and the liquid molecules attaches with the solid molecule and they used to move up. The molecules which are in contact with the solid are attracted by the solid adhesive force, and remaining molecules which are away from the surface are attracted by the cohesive force. The cohesive force is smaller and adhesive force is more. Therefore, more number of molecules are attracted towards the solid and the molecules goes up, and because of that the liquid surface become concave. And because of that, liquid rises inside the capillary tube. This is the rise of liquid inside the capillary tube. And for the liquids in which this cohesive force between the liquid molecules is greater than the adhesive force between the solid and liquid molecules, the molecules of liquid are attracted by greater cohesive force and therefore they will move away from the solid surface, and because of that the liquid get depressed inside the capillary tube, and hence there is fall of liquid inside the capillary tube. This rise of liquid or fall of a liquid inside the capillary tube is called as capillarity or capillary action. We can explain this capillarity or capillary action on the basis of the pressure difference. Very simple thing we are going to do. This is the capillary tube of a very small bore. Let it is a capillary tube of a glass. It is immersed in a liquid which partially weighs the solid. In this case, the liquid surface at the point of contact will be a concave. Angle of contact is less than 90. And this is the condition before liquid rises inside the capillary tube. For the sake of convenience, we will consider the 4 points as shown in the figure. What it is? A is the molecule of a liquid. A is the molecule of a liquid just above the concave side of the liquid. B is the molecule of a liquid just below the concave side, and A and B are inside the capillary tube. C and D are on either side of horizontal liquid surface. Therefore, what will happen here? The pressure at point A is greater than pressure at point B. Why? The pressure on the concave side of the liquid is more than that of the convex side of the liquid. This is the thing that is known to us. There is no difference of pressure on either side of horizontal liquid surface. Therefore, pressure on C is equal to pressure on D, because these two are on horizontal part of the liquid. Liquid at the point of contact is concave, but at the rest of the time the liquid surface is horizontal. Now, pressure at A is equal to pressure at C, because both are in air, both have the atmospheric pressure. Let it is represented by P0. Pressure at A is equal to pressure on C, and pressure on A and C is equal to atmospheric pressure, because both are in air. With this, what we are able to say here is that A is equal to C, C is equal to D, therefore A equal to D, therefore pressure at D is greater than pressure at B. Pressure at a point D is greater than pressure at a point B. And liquid always flows from higher pressure to lower pressure, and because of that the liquid flows from D to B, and hence liquid rises inside the capillary tube until the pressure at D becomes pressure at B. The rise of liquid is possible until the pressure of the two will become equal. Now, here what is interesting to note that B and D are at the same level initially. B and D are at the same horizontal level initially, but pressure at B and D is different, and because of that there will be a rise of liquid inside the capillary tube until the pressure at B becomes equal to pressure at D, and hence because of this pressure difference the liquid rises inside the capillary tube, and hence there is a rise of liquid inside the capillary tube. Now, in a similar manner, with the help of pressure difference, we are able to explain why the liquid surface is convex in a case when liquid do not weigh the solid. For that, we will consider this example. Here, what you will see that as the liquid surface is convex, what you will see here, the pressure at B is greater than pressure at A. Because pressure on the concave side is more, therefore pressure at B is greater than pressure at A. Or pressure on convex side is less. It means that is pressure at A is less than pressure at B. Pressure at A is equal to pressure at C because both are in air. Pressure at C is equal to pressure at D because both are on either side of the horizontal liquid surface. And from this, A equal to C is equal to D, therefore pressure at B is greater than pressure at D. The pressure at B is more and pressure at D is less, therefore liquid flows from B to D and hence liquid depresses inside the capillary tube and hence there is fall of liquid inside the capillary tube. This is how liquid rises or falls inside the capillary tube depending upon how much is the angle of contact. We know that here what you will see, this is the tangent drawn to the liquid surface at the point of contact. The angle measured from the side of liquid, this will be the angle and this angle is obtuse angle. This is the tangent drawn to the liquid surface at the point of contact. The angle measured from the side of liquid, this is angle of contact theta and this theta is less than 90. The reason is again here the resultant of adhesive force between the solid liquid molecule is more than that of the cohesive force between the liquid molecules. With this explanation of why there is rise or fall of liquid inside the capillary tube, now we are going to derive expression for the ascent of liquid inside the capillary tube, or we are going to derive an expression for a rise of liquid inside the capillary tube. Let us consider liquid rises to a height h inside the capillary tube. Now, to what height the liquid will rise inside the capillary tube? Liquid will rise inside the capillary tube until the pressure at point B will become pressure at point D. We know that the pressure on the concave side of the liquid is more. Pressure on the concave side of the liquid is more and pressure on the convex side of the liquid is less. And we know the Laplace formula for the pressure difference. Therefore, pressure at point A minus pressure at point B, the pressure difference on the concave side and convex side, is equal to 2T divided by capital R, where capital R is what? The radius of the meniscus of the liquid. Now, let us consider this is the meniscus. Now, we will draw a sphere for this one. The radius, this is the center of the sphere somewhere. Let it is represented by O. Now, this much is the radius of the sphere, capital R. Radius of the meniscus. Pressure at B is less than that of the pressure at A, or pressure at B can be written as pressure at A minus 2T divided by R. This is the pressure difference that we know from our previous knowledge. The excess of pressure inside the liquid drop, and the excess is 2T divided by capital R. This formula we have derived earlier. Now, the pressure at C is equal to pressure at D. Pressure at C is equal to pressure at D is equal to pressure at A, because C and D are on either side of horizontal liquid surface. A and C are in air, have an atmospheric pressure. Let us consider there is a point E which is exactly on the same horizontal level of D. Therefore, pressure at E is again equal to pressure at D. Now, what you will see here is that pressure at E is equal to the pressure at point E is equal to pressure at point B plus pressure due to liquid column B to E, and the liquid column B to E has a height h. Therefore, it is plus h rho g. Pressure at E is equal to pressure at B plus pressure due to a liquid column, that is PE is equal to PB plus h rho g. Now, with this, I will write the pressure at E is equal to pressure at B. What it is? Pressure at A minus 2T divided by capital R plus, I will write this, h rho g, where h is height of liquid inside the capillary tube measured from a liquid outside the capillary tube, or rather it is rise of liquid inside the capillary tube. But PE is equal to PA, therefore I will write PA is equal to PA minus 2T divided by capital R plus h rho g. PA get cancelled, therefore h rho g is equal to 2T divided by capital R. And from this I am able to write that capital H is equal to 2T divided by R rho g. This is what the rise of liquid inside the capillary tube. But dear friend, here if small r is the radius of the capillary tube, small r is the radius of the capillary tube. In that case, if this angle is theta, what about this? This is radius and tangent. These are perpendicular to each other. Therefore, this angle is of 90. And this remaining angle is of 90 minus theta. And in this right angle triangle, this is theta, this is 90, this is 90 minus theta. Sum of all these angles will be equal to 180. And sum of the angles in the triangle is 180. This is again a right angle. This is, if it is 90 minus theta, it is 90. Obviously, this angle will be equal to theta. Now, if this angle is equal to theta, for this angle theta, R is the adjacent side and capital R is the hypotenuse. Therefore, I will write the cos theta is equal to, here I will write What this cos theta is equal to? Adjacent side divided by hypotenuse. Therefore, capital R is equal to small r divided by cos theta, and hence I will get this equation. What h is equal to 2t divided by r. Denominator will go in the numerator into cos theta divided by r rho g. Therefore, h is equal to 2t divided by 2t cos theta divided by r rho g. This is the equation that is called as the formula for the ascent. What are the factors on which the rise of liquid inside the capillary tube depends on? The rise of liquid inside the capillary tube depends upon the surface tension, the angle of contact, the density of liquid inside the capillary tube, and the radius of the bore. From this formula, what I am able to write is that the rise of liquid inside the capillary tube is inversely proportional to the radius of the capillary tube. Smaller is the radius, thin is the capillary tube, more is the rise of liquid inside the capillary tube. Therefore, the roots which are having very small bore are able to absorb water and mineral from the earth and provide this water and mineral by capillary rise to the leaves and fruits at the top of the trees. The wick, which is dipped in oil, is able to rise the oil upside against the gravity because of capillary of threads by which the wick is produced. साधी गोष्ट आहे. आपण एखादी वीट पाण्यामध्ये बुडवली तर विटेमध्ये पाणी ग्रॅव्हिटीच्या अगेन्स्ट वर चढतं, कारण विटेच्या मध्ये असलेल्या पार्टिकल्स मध्ये जी कॅपिलरी तयार होते त्या कॅपिलरीनी ते पाणी राईज होतं वरल्या बाजूने अगेन्स्ट ग्रॅव्हिटी. दिस इज कॅपिलरी ऍक्शन.